All right, ladies, so in all of the discussion today involving the limit definition of a derivative, I forgot to go over some shortcuts, or I should say rather we ran out of time for some shortcuts. So I kind of want to just do a little amendment and addendum to today's lesson. Okay, you should have seen these shortcuts in PreCalc. In fact, I know you've seen these shortcuts in PreCalc, but I want to make sure I teach them to you as well. I don't want to assume that you just know something. So that's what this video is all about. So, some of the problems are going to ask you to use the thing called the power rule to take a derivative. This is the easiest derivative shortcut ever. It's going to turn all of that limit nonsense we did today into something that, quite frankly, you'll be able to take derivatives visually just by inspecting the problem. So, essentially what the power rule says, for any exponent, x to the n, if you want to take the derivative of x to the n, all right, I'm going to show you a new notation, d over dx, the derivative with respect to x of x to the n is just equal to n times x to the n minus 1. You just bring down the power and subtract a 1 from the exponent. So for instance, the derivative with respect to x of x cubed is 3x squared. Okay? I'm going to prove this in class tomorrow, but I want to at least show it to you so you can do the homework tonight. Now, you might be saying to yourself, well, what about exponents that aren't nice, pretty integers? What if I want to take the derivative with respect to x of x to the 3 halves? Hey, guess what? We can do the same thing. We bring down the 3 halves. It's 3 over 2 x to the 3 halves minus 1, which is 1 half. Okay? What if I said the derivative of 3x to the 2/3? Same thing. Bring down the 2/3. I get 2 because I do 3 times 2/3. X, I subtract 1, negative 1/3. If you don't like that negative exponent, you can write 2 over x to the 1/3, and that makes that 1/3 a positive. Okay, that's the power rule. Remember, too, that there's also rules involving sums and differences. So, if you have two functions, f and g, and you want to take their derivative, and you want to add up their derivative, it's just the derivative of the first function plus the derivative of the second function. Same thing if you have a difference. So if you want to take the derivative of a difference, f minus g, you just take the derivative of the first piece minus the derivative of the second piece. That's what basically helps us take derivatives of polynomials. So for instance, if I have f of x equals 2x cubed minus 3x squared plus 2x, and I want to take its derivative, I'm just going to do the power rule to each of the 3 terms. I get 6x squared minus 6x plus 2. Look how fast derivatives become once you know this rule. All right? So this should be enough for you to do your homework tonight. I just wanted to show it to you now. We'll do more of it in class tomorrow. I'm even going to try to at least prove one of those rules to you using the limit definition. And then I promise you, once we prove the rule using the limit definition, unless I absolutely insist for you to use that definition in the directions to a problem, we're going to use this shortcut from now on. All right? Have a good evening. If you have any questions about any of this, please email me, come see me tomorrow morning, and we'll do our best to make it work. Have a good night.